Today we're going to take a look at circles. It's the only other shape on our formula sheet we haven't talked about yet. We've done sort of all the ones with straight edges. Let's take a look at the ones with the round edges. So we'll start with perimeter. Perimeter of a circle requires a special formula because you can't really measure it. You could take a string and lay it down on the outside and straighten out and measure the string, but you can't really do that with a ruler, right? So we have a special formula, and we actually have a special name for perimeter of a circle. We call it the circumference, the distance around your circle. When you use this formula, you actually have two different choices. It depends on if you want to use the radius, which is halfway across the circle, so from the center out, it's called the radius, or do you want to use your diameter? Your diameter measures the distance all the way across the circle. So if I went from one edge all the way through the middle to the other side, we call that our diameter. Here's our formulas. Circumference is pi times d. When things are stuck together, it means they're going to multiply. Or you could use 2 pi times r. And the reason that formula works is the diameter is always 2 radiuses. Look at your picture here, right? Here's one radius, and here's another radius. What? That's all the way across the circle. In other words, the diameter. Doesn't really matter which one you use. They work the same way. We'll look at some examples and try them just to understand how this works. We've got to talk about pi here for a second. When we get to our calculators, we're going to try and use our pi button. Okay, pi is that long, never-ending decimal, 3.1415 ... keeps on going forever and ever and ever. Because of that, we'll try and use the pi button because it remembers more of the decimals than we do. All right, let's take a look at what kind of things we can do. I want to find the circumference of each circle. Circumference is just a fancy word for perimeter. So circumference equals. And I have a choice. I can use 2 pi r or pi d. Either one's applicable. I just have to understand from my diagram which situation do I have. So looking at our diagram, I have to look at this measurement right here. I notice it goes from the center outwards. That makes it a radius. It makes sense to use this formula. So 2 pi r. But what is r? It is 3 feet. So because it's all stuck together, it means it's multiplying. I'm going to multiply this all together. Let's take out our calculator for a second here. Turn it on. Okay, so I'm going to do 2 times. Now, somewhere in your calculator, there's a pi button. Okay, on this calculator, I have to search for it here for a second. Oh, it's in a really funky spot. And it's right here, above the exponent button. That's a pretty tricky place to find it. How do I get to that? Well, on my calculator, I'm going to use my second function, and then pi. Pi. Right, wrong one, guys. Second function, pi. There we go. Times 3. And most calculators, actually all calculators, have a pi button. You're just going to have to find it on yours. And if you really couldn't find one, or you're using a really basic calculator, you could type in 3.1415. But it's easier to use the pi button because it's more exact. It's better. And our answer comes out to 18.85. Every question today is going to have decimals in it because pi is a decimal. So try and give me 2 decimals if you could. Don't forget units. In this case, we're talking about feet. Anyway, take a look at the next one. Circumference equals. What's my situation? Well, I go all the way across the circle. That means this is a diameter, which means I'm using pi times d. And so same idea. Put in the 12 this time. The 2 is not necessary like here because we're not talking about radius, which is pi times 12. And we get 37.7. And that's meters. Now, to point out, you could have turned this into a radius if you really wanted to. Radius goes halfway across the circle. The radius would be whatever 12 divided by 2 is. That's 6. So if you use that formula, 2 pi times 6, well, isn't 2 times 6 really 12? It's the same thing, right? Just doing it in a different way. That's why the formula works either way. All right, try the third one, the weird one here. What do we got in this shape? Well, it looks kind of like a circle, but it's half a circle. So how do I find my perimeter? Well, I need my curved part, which we call our circumference. So I got pi I've got the distance all the way across the circle. That's a d diameter. So pi times 4, which comes out to, oh, not just pi times 4. How come? Well, isn't that half a circle? So I'm going to have to divide this by 2. If I do that, we end up with 6.28. It can be a little bit tricky here because that only gives us the distance around the curved part. We've also got this on the outside of the shape, right? We're going to have to add our 4 in at the end. And we end up with 10.28. And we're talking about kilometers in this case. And so remember, our idea of perimeter is the distance all the way around the shape. Just a regular circle like these ones. Just use our circumference formula. But if we have an extra line on the outside, we have to include it also. So we'll take that idea to the next step. I want to find the perimeter of these shapes. These shapes involve circles, but not necessarily entire circles. So if we take a look at this first shape here, this orange one, the perimeter is the distance around a shape. So I've got to go around the top, down the side, across the bottom, then around the curve. So if I think about that, my perimeter is made up of a 4 across the top, a 3 on the side, a 4 on the bottom, and this curved surface, which is half of a circle. To find half of a circle, I can take my idea, either pi times d or 2 pi r, to interpret the situation. What do I know about this distance? Well, isn't that also 3? In other words, the diameter, so pi times the diameter. But this curved surface isn't the entire circle, it's only half a circle. So I'm going to divide by 2. If I add all these things together, I get 4 plus 3 plus 4. That's 8, 11 plus pi times 3 divided by 2 is 4.71. And add that together, I got 15.71 centimeters. Now notice I didn't add another 3. The 3 is on the inside of the circle, of the shape. So I used it to find the curved surface, but I didn't actually add it in because it's not part of the perimeter. Okay, we'll try the next one here. I need to go all the way around this shape. Around. What do I know about the around pieces? Well, that's 10, and so is that. Okay, I've got to walk all the way around the curved part and around the curved part at the bottom. If I take those two curved parts and put them together, doesn't that make a circle? So what do I really have here in this shape? Well, my perimeter is made up of a 10 and a 10, the two sides, plus a whole circle. A whole circle. A whole circle can be pi times d. Do I know the diameter? Yeah, I do. These little dashes are all 10s. So pi times d, my diameter must be 10. So I'll get 20 plus 31.41 comes out to 51.41 meters. So I think about my shapes. What do I have here? Do I have circles, whole circles, part circles? And what surfaces are on the outside? I include those when I talk about perimeter. Again, notice I didn't actually include this number or this number because they're not on the outside. They're on the inside. They're not part of the perimeter. All right, second half of the lesson. Circles also have areas. To find the area of a circle, we have to use radius. So pi r squared. If you're given the diameter, and my diameter, I have to convert that into a radius. And my radius, oops, that is not how you spell radius. My radius is always the diameter divided by 2. I have to use it. Notice I'm using my pi button again, and actually my squared button like we did in Pythagoras. Okay, we'll try some. Same shapes, just to find the area this time. So my area is pi times the radius squared. Do I have the radius? Yes. Center outwards is a radius. So pi times 3 squared. Now you should be able to type that all in your calculator at one time using your pi button. So pi times 3, use your exponent button, make it a squared. You get 28.27. We're talking about areas, so it's going to be feet squared. And try and use your pi button, try and use your exponent button. It does it all at one time for you. Let's take a look at B. I want to find the area still. Area is pi r squared. What is my radius? Well, they didn't give it to me this time. They give me the diameter all the way across. I only want half across. So my radius is always the diameter divided by 2. So I get 6 squared. And you type into your calculator again, you'll get 113.09 meters squared. And try the third one. What shape do we see here? That's that half circle idea. Still the same formula, pi r squared. Do I have the radius? No, I got all the way across. So I want halfway. 4 divided by 2 is 2. Okay, so I've got pi times 2 squared. But remember, that's a whole circle, and we only have half. So what am I going to do afterwards? I'm going to divide this by 2. So I can actually type that all in my calculator at one time if you wanted to. Nothing wrong with that. You should get 6.28 kilometers squared. And if you don't want to do it all at one time, do the pi r squared for get what your whole circle is, and then just take your answer and divide it in half. Divide by 2. Works the same way. Okay, let's look at those weird shapes again, but this time the area. So what do I have in this shape? Area. I've got 2 shapes. I've got a rectangle at the bottom, rectangle, and plus I've got a half circle. So we have formulas for these. Rectangle is length and width. A circle is pi times r squared. And if it's half of it, I got to divide it by 2. Okay, length and width. Well, those are obvious. There's my length, there's my width. 10 times 8 plus pi times my radius. Do I have the radius? Oh, center out. No, I don't know that, but I know the whole thing all the way across is 8. So my radius must be 8 divided by 2, which is 4. Okay, don't forget we need that divided by 2 at the end, because I want to divide my circle in half. And if we do this, we'll get 80 plus 50.26, or 27 divided by 2. Just showing you how we can do it in stages if we wanted to. And make sure we're following BEDMAS rules still. So 50 divided by 2 comes out to what? 25.13. If we add that together, we get 105.13 feet squared. Okay. Again, if you wanted to, you could have typed this all in at one time and gone directly to this number. There's nothing wrong with that. I just showed you how you could do it in 2 steps if you wanted to. The whole circle divided by 2. Okay, last one. Okay, what is the area of the shaded region? Can we figure this part out? Ooh, that's a tricky question. But that I had to fix the lesson. I was missing the wrong example. Okay, area of this shape. What do we see in this shape? Well, in the middle here, we have ourselves a rectangle. Oops, rectangle. Jumping ahead of myself there. And what else do we have? We've got half a circle up top combined with half a circle down the bottom makes a whole circle. So what do we need? Rectangles, length times width. A whole circle is just pi r squared. Let's go find the length and width of this circle. Or sorry, rectangle. It's definitely 10 wide. And well, it's actually the same, right? There's that dash. It's 10 long. Plus pi. What's our radius? Our radius would be from the center out. Well, we know the whole thing is 10. So the center out has to be 5, right? Radius is 10 divided by 2. So it's 5. Okay, 2 separate things. 10 times 10 is 100. Pi times 5 squared, 78.54. And add them together afterwards, we get 178.54, and this is meters squared. And there's the area of the circles and the perimeter of them, which we call circumference, as well as some of those weird shapes. You can combine things together. And we're going to start doing more of that, combining shapes together. It's easier if you break them down to small things that we know how to do first. Try this sheet on the website. If you're stuck, come see me. And we're going to move on to other things we can do with shapes pretty soon.